So, in the last video, I was talking about transparent integration, and we showed one example of that. There are a couple additional use cases, and we'll show those uh, in this video. So, let's start by looking at the code that transparent integration enables. And what I'm looking at is a repo that contains a federated microservice, a federated application component. Right, one of the components that will be loaded by the federated application, the Aegis server. Okay, so this is the code for the order service, and here we see that uh, when we're processing the order, we are checking for a customer ID to see if we already have the information, like shipping information, already on hand. Um, and if we do, we fill in that information automatically into the order from the customer. So when in the specification, the model specification, let me quickly show that. We specify a relation called customer that specifies the details of the relationship between customer and order. This is the order specification. So it defines this relationship to customer. And going back to the order service, when you specify a relationship like that, the system automatically generates a method on the model, in this case the order model, with the name of the relation, customer, and it allows you to invoke, as we saw in the last video, it allows you to instantiate that the relationship, the customer object that the relationship refers to, which is happening here. So what that means is that we're not doing a database call, right? This isn't a database call. We don't necessarily have access to the data store. In fact, um, the this might be on a part of the network that simply doesn't have access. And as a general rule, one microservice can't see even though we're calling the customer, itself. Just as a general rule, one microservice can't see the other's data. That data is hidden for a good reason. We've discussed that before. All right. So if we can instantiate this customer object, then we can call methods on it. And again, these methods are really behind the scenes. They're ports. Um, uh, if you recall, hexagonal architecture, ports and adapters, that paradigm is used in Aegis to ensure that there's strong boundaries between components. That's the only way that objects can communicate with one another. There's different methods, but in the end, it's one of the predefined integration points. And this one happens to be particularly easy to use, as we'll see, because it completely abstracts the fact that these objects are remote from one another, and it's not, this isn't Corba or something like that. It's an RMI. It's something I would say much simpler than that. There's no protobuf. There's no configuration that you have to worry about at all, apart from that relation that we just showed. All right, so let's say that this customer ID is null, right? We don't have it's a new order. from a non-customer. So what we'll see here in another use case is that we want to save the details of that customer, right, and actually create a customer record from that detail. And what we see here is that we're passing arguments into the customer method, and actually that's just the decrypted details of the order. The order and the customer, for sake of simplicity, have like overlapping data. That may or may not be the case in your system. Regardless, what's being shown here is that you can actually create a customer record, not just reference one. And you can create several depending on what the relationship is. In which case you would specify the input to that model that's needed for creating it. So we'll take a look at both of these in action. Right. So I've got two services running just on my local host. One that's running orders and users, and the other, so that's on 8070. This is 8072, and this is running customers and products. Okay, so they don't have order or users loaded on 8072, and this instance doesn't have customer or products loaded. They know nothing about those. They know nothing about that software. They know nothing about that data, the schema. They know nothing about each other at this point, apart from the relationship that we saw. So when it comes time to reference, utilize that relationship, what we're going to do is we'll show the first case where we want to bring back the customer record, where we're going to reference the customer record in the input. So let's just select a customer record that maybe we haven't seen before, hopefully. And what we'll do is we'll say this is what we saw in the last video. So we'll create an order and reference that. Why not running? Yeah. Where was that? Yeah. I guess it's not running. Okay. Let's fire that up. Okay. Should work better now. With the software actually running. Okay, so let's do this. All right. So we're going to show an example of transparent integration where we're creating an order that references a customer on a server where customer does not exist, and we're going to the transparent integration takes care of that behind the scenes with distributed object caching, and we'll get into that in a sec. So let's just post that. And we'll see that I didn't have a first name, but it was able to fetch that data anyway, and that was through the distributed object cache. And we should also be able to see relationship to customer. Yeah, here it is. Despite the fact that it didn't know about that object when I started up, actually until I requested that object. Then it looked at the relationship that's defined and requested that information. So that's an example of on-demand fetching of the information when it doesn't yet know about it. But this customer record existed before before there was any relationship defined between customer and order, let's say. So it would have never received a notification. The other case is where I can create a customer record. I need to change the email, otherwise it will complain. So this now that when the relationship has been defined, right, at startup, the system is going to request notification of any cache events for that domain. So now, when I create a customer, any systems that are interested in cache events for customer will receive a notification through the event bus, whatever that happens to be in your architecture. Really, it could be anything. In this case, we're using Kafka. You could set it up with a WebSockets integration too, but to make it as to make it as easy as possible, right? Without having to know, cross network boundaries, without having to know about domain names and firewalls, etc. There's a presumption that any microservices implementation is going to have an event backbone or event bus. So this would just plug into that. For basically, there's a channel that you would create called broadcast, a broadcast channel, a topic, right? And that's where this traffic, the traffic of the distributed object cache would occur. So those are two use cases, and then there's the use case where we actually create a new customer. So let's go ahead and say that we want to save the shipping details of this brand new customer. And again, let's make that email address unique. Right. So there's some business logic there, some verification, some validation logic that's running, doing its job. Could have had some fun with that, but all right. So now we said to save this information, okay? Which means we're creating a new customer in this example. So you can see that we didn't send in a customer ID. That was created for us, and that's also a use case that's supported by the object cache and the transparent integration. All right. yeah, and again, it's important to understand that. We'll look at the code once more. Also, we can see that this is. Also, we'll have a relationship, right? Um, let's uh, let's close this up and just kind of summarize what we talked about. So, the distributed object cache is not uh, masking some kind of database call. It's not RPC. It's not RMI or any kind of like object request broker. Corba, anything like that. gRPC. There's no configuration apart from the relationship that you define. Then you can deploy your objects however you like, remotely or together in the same process. And you just write one, you write the code one way, and it works regardless of how they're deployed. Which we'll take another look at that code to close out. So yeah, let's just see this real quickly again. We're going to create a new customer record. I think. Okay, that's complaining about the email. There we go. And it would have come back with an error that the email is not unique, right? So what we're able to see is that we created that customer. The relationship, it's linked to this order now. Here's the customer record. So another thing that's important to understand here is that what's actually happening is that not only are we seeing the data for the first time, but also the code that controls the data is being streamed over the network at runtime. So this allows the host to basically handle new data and new software dynamically. Which opens up a lot of doors. And then let's just take a look at where we create a relationship. Again, I have to change the email. And if we copy this ID and we plug it in over here, right? Here's that customer record that showed up over here, because now we're subscribing to that domain's cache, to that object's cache. And then let's just check out the code real quick. So all I'm doing is calling this method that the system generated for me to retrieve the customer record. Or in this case, I'm calling that same method but providing input arguments so that I can create a new customer record. So you can achieve that, deploy wherever you like, and achieve that simplicity of coding without deploying wherever you like, and writing the code just consistently one way. And that provides some pretty simplistic integration when you think about the trouble that people have to go to in microservices when they start dividing up their app and baking all these APIs. This trivializes that process to the point where you don't even know if you're running local or remote. You don't care. You don't need to know that. Obviously, for performance reasons, you need to choose your deployment wisely. If these two are running together in the same process, this call is much faster, right? We never go onto the network. It's just all in memory. So I think that's all for now, and check back again for the latest. I'm sure we're going to have some more videos. Thanks for watching.